SLIM's unique and proven methodology, built on empirical data and research, solves your estimation challenges. Software estimation is often confused with high-level management goals, releasing a product in time to meet a market window, outbidding competitors and winning business, as well as detailed planning activities, constructing a work breakdown structure, or listing the tasks needed to execute a project. Unlike goal-based estimates, we need this in 6 months for under $5 million. Capability-based estimation is a technical calculation of what a team might be able to do, assuming a given scope, cost, schedule, staff, and uncertainty level. Typically, projects overrun their estimated schedules and budgets for the following reasons: unrealistic goals that exceed current capability, not estimating scope like the volume of features to deliver, failure to re-estimate when scope creep occurs, and not understanding the consequences of adding staff to reduce schedule. In this video, we will show how empirically based SLIM estimation tools drastically reduce estimation time and effort and deliver achievable results grounded in actual performance data from real projects. Estimating software projects is challenging because estimates are typically needed when we know the least. Often stakeholders want a single-point estimate based on hidden assumptions, yet they expect pinpoint accuracy. Having empirical data at your fingertips helps you communicate more effectively and negotiate achievable plans. The first step to creating defensible estimates is to recognize why we perform estimates: to support bids and win new business, to prioritize features and projects, to expose no-win scenarios before we sign up for them, to assess and secure required funds, resources, and skills, to set realistic expectations and negotiate achievable commitments, and to identify and mitigate risks. Often, the purpose of the estimate drives the estimation approach. A key function of estimation is to provide visibility. A good process prompts you to ask questions, thereby bringing misconceptions and risks out into the open, and make sure everyone understands and agrees what they've been asked to do. Organizations sometimes confuse these terms and the business practices that they represent. The term estimate is often misused. If you think about a project that you're working on, it has a target or something that we hope to achieve by running this project. But then there's always something that holds us back, constraints. We may not have the time, money, or the resources. An estimate is simply a calculation of what we might be able to do, assuming a given level of scope, cost, schedule, staff, and uncertainty level. Too often, commitments are based on targets rather than past performance. The ability in SLIM to run several estimate calculations and then compare them to one another lets us make a commitment to the one estimate scenario that balances our risks and rewards. The plan comes later. Estimates should be based on proven performance, not aspirations, client desires, or detailed task lists. Estimation is challenging because estimates are needed early in the project lifecycle when very little hard data or knowledge is available. Because so much about the project is unknown, the level of uncertainty and therefore risk is high. Uncertainty about final size, effort, schedule, cost, defects, and productivity decline as the project progresses, but never completely disappears, even once the project is completed. SLIM uses the best available client and industry data to produce a defensible ROM estimate that can be quickly and easily updated as we learn more. Estimation is both a technical calculation and a communication and negotiation process. Chances are, if 6 people in different roles think about an upcoming project or release, they're visualizing completely different beasts. A good estimation tool brings hidden assumptions out into the open. Consistent processes and measurements give teams a repeatable framework for analyzing and discussing the work to be performed. Mapping to any framework requires time and effort. The payoff is that everyone discovers which part of the elephant they weren't thinking about. Viewing the elephant from multiple angles provides a more complete picture. Software metrics should support their intended use. This is true whether you are estimating a new project or benchmarking a completed one. How would you describe an elephant to someone who had never seen one? That probably depends on what they need to know about the elephants. The detailed versus summary level view, both are accurate, both are useful. If you've been asked to draw an elephant, the detailed view makes more sense. But if you're building an elephant house, the summary view is more useful and practical. What you need to know depends on why you need the information. Estimation falls in two broad categories. Bottoms-up estimates decompose all the work required to build the product into detailed task list. Estimate duration and effort for each task, and then some task estimates to produce an overall schedule, cost, and effort estimate. It requires detailed knowledge you may not have yet, typically performed by people doing the work, better suited to planning than upfront estimation, and it includes both the role-based and the task-based approaches. Top-down estimates combine summary-level metrics from similar completed projects and observed relationships between the project variables. We estimate the product size, make an assumption about productivity, and time and effort are typically outputs. For early estimates, detailed task or role-based estimates suffer from a mismatch between the data available and the data required to create the detailed task list and estimate the effort and schedule dependencies between each task. These kinds of estimates are closer to planning than upfront estimation. The high level of detail required makes them difficult to revise and update when the landscape changes. Top-down estimates require fewer inputs that are easier to capture consistently at project closeout, and estimates can be quickly updated. We can use historical data to tune estimates to our past performance and benchmark against the industry. What makes an estimate good? It's timely. It can be performed when it's most needed. Defensible, backed by data. Transparent. Assumptions are known. It evaluates multiple solutions, explores a range of potential outcomes. It accounts for likely risk factors, the probability of achieving our targets. Contingency is explicit and scaled to risk. And productivity assumptions are tied to actual performance. It's easy to revise, and it provides a consistent and repeatable process. How SLIM works. SLIM's top-down approach models any development project type and methodology by using two high-level building blocks, sticking with 5 core metrics: size, time, effort, defects, and productivity, and the definition of 4 life cycle phases that provide a framework for modeling different development life cycles. Core metrics create a common language, a frame of reference. Consistent measurement comparisons require consistent definitions. For example, if you're using a productivity metric of hours per function point, what effort activities are reflected in the numerator? Focusing on summary level metrics decrease the cost of measurement and promote industry internal comparisons. All product development projects perform the same basic activities. So modeling your environment is simply a matter of knowing how much time and effort is spent in each phase and the level of concurrency. SLIM can be configured for waterfall, agile, or hybrid development methods, which may include different phases and spend different amounts of time and effort on certain activities. SLIM provides objective, expert judgment in a box. QSM Industry Database and Trends supplies major inputs of those core metrics, and it's used to validate the reasonableness of the estimate. QSM has a global database of completed projects, over 13,000, collected from clients in industry. SLIM ships with 17 trend groups, including system software, agile, package implementation, government, and finance. Core metrics scale non-linearly with project size. These relationships are robust and consistent over 38 years and across domains. Empirical knowledge of these relationships is built into SLIM estimates algorithms, charts, and reports. Not only is history used as the source of major inputs, ensuring estimates are based on known capabilities, but comparing past performance, both industry and yours, lets you instantly assess whether estimates are reasonable and what assumptions should be challenged. Is the staffing too high or required productivity unattainable? The best practice of gathering your own completed projects lets you adjust key estimate inputs based on averages from your projects and generate a balanced risk solution based on your history. Productivity and the software equation. Let's take a dive to understand the dynamics of software development projects. The software production equation is at the heart of SLIM tools developed by Larry Putnam Sr.'s original work. The size of the system and the value delivered is proportional to some amount of effort applied over some amount of time at some level of productivity or efficiency. For straightforward estimates, inputs are typically size and productivity. The outputs are time and effort. Productivity in SLIM is not a traditional linear measure, but describes the efficiency of the whole project environment. Much like this pipeline, software project efficiency can be determined by the capacity of the environment itself, plus the difficulty of what you're trying to push through it. Productivity is affected by a host of factors, some of which can be quantified and some of which cannot. Personnel factors, technology factors, process factors, and the product itself, plus reuse. Rather than attempting to identify and predict each and every factor, SLIM takes a different approach. It captures the total effect of all these factors, whatever they are. We know from Larry Putnam Sr.'s original work and the scatter plots we saw earlier that schedule, effort, defects, and productivity all increase non-linearly with size. Size is a measure of the project scope. Ignorance of size leads to bad estimates because size determines the time and effort required. Schedule, effort, cost, and complexity are influenced by size, but not equivalent to size. It is especially challenging for folks used to bottom-up estimating not to specify effort as a measure of project size. We'll see soon that time and effort are trade-offs, so how much effort is required is driven by the schedule, and vice versa. Size is a proxy for the functionality or the value of the system being built. We're capturing the work that has to be done, not how long it takes, but what is the actual work being done. A closer look at the software equation, namely the exponents on effort and time, show that not only are these related non-linearly, but that time has the greatest impact. We always want to get a project done as quickly as possible, but that is often a risky scenario. Projects can be scheduled and staffed in different ways, but for a given project, same size and productivity, time and effort are never completely independent. You could choose to take more time and not only reduce staffing and cost, but increase quality. If you have to increase effort to achieve a schedule goal, okay. Going too far in either direction gets you into the impossible and impractical zones. SLIM lets you know where these zones are. Early estimates often require us to combine what we know, often very little, with reasonable assumptions about what we don't know, often a lot. The software production equation can be rearranged to produce different solution methods that takes advantage of these two factors. The fixed resources method determines how much functionality or scope over a certain amount of time is used to determine a design-to-cost solution. The time box fixed team method calculates the delivered size given a certain team size, delivery schedule, and productivity. Good for our agile teams. The bid evaluation method calculates the productivity needed to build a certain amount of functionality within a certain amount of time and effort or budget. This is used to determine the feasibility of bids and benchmarking. Uncertainty and risk. Explicitly quantifying uncertainty enables you to manage it because you can't eliminate uncertainty. Imagine a project building the same product 100 times. Because the productivity, work plans, team size, costs would naturally vary, they will not always achieve the same outcome. Some projects would be under budget. Some projects would be over budget, under schedule, over schedule. But what we find is that most projects will come in somewhere around the middle. In SLIM estimate, we're translating the uncertainty about the inputs to uncertainty around the outputs, schedule, and budget. Now, there is not a single point estimate. We have a range of potential outcomes. The width of the curve depends on the number of variables and uncertainty around each one. Most solutions in SLIM represent the expected or the 50% probability solution, but you can add constraints to get a risk-buffered solution. The constrained solution method generates a 50% work plan with enough buffer to meet your targets and desired probability. For example, being 80% confident of not exceeding the life cycle duration of 7 months. Even though we calculate that this project can be completed in 7.13 months, we commit to the customer to deliver in 8 months. This gives us about 3 calendar weeks of reserve to respond to risk which might threaten the schedule. Without this risk reserve, the moment one problem compromises the schedule, we are in danger of overrunning and not fulfilling our commitment. The top-down approach produces defensible estimates early in the life cycle when little bit is known. Estimates are defensible and reasonable based on known capabilities. You can quickly run multiple scenarios to explore the range of potential outcomes and commit to the best solution. Explicitly dealing with uncertainty and risk allows us to compute contingency appropriate for project risks. To learn more about the SLIM estimation benefits and our tools, please contact QSM.